I am Mrs. S.R. Ghorpade. Welcome you all in today's video session. Today we are going to learn more about some of the field devices which are commonly used in connection with the input-output modules. After completion of this video session, you will be able to identify the functions of electromagnetic control relays, contactors, and the motor starters. Our first field device is the electromagnetic control relays. Now, what is the basic purpose of PLC? PLC's original purpose was the replacement of electromagnetic relays. Although the PLCs has replaced much of the relay control logic, electromagnetic relays are still used as an auxiliary devices to turn on or turn off the input-output field devices. The programmable controller is designed to replace the physically small control relays that make logic decisions, but are not designed to handle much heavy loads, much heavy current or much heavy voltages. An understanding of electromagnetic relay operation and the terminology is important for correctly converting relay schematic diagrams to ladder logic programs. An electrical relay is a magnetic switch. It uses electromagnetism to switch contacts. A relay will usually have only one coil but may have many number of different contacts used in it. Here, the circuit shows the schematic for the electromagnetic control relays. In this figure, we can see the structure of the electromagnetic control relays. With no current flow through the coil, that means when the coil is de-energized, the armature is held away from the core of the coil by using the spring tension. When the coil is energized, it produces an electromagnetic field in between the coil and the contact. Due to this electromagnetic field, the physical movement of the armature causes. Movement of the armature causes the contact points of the relay to be open or to be closed. The coil and contacts are insulated from each other so that under normal conditions no any electric circuit will exist in between the coil and the contact. Figure here shows the symbol for the electromagnetic control relays. Here, the contacts are represented by the pair of short parallel lines. There are two different symbols for the electromagnetic control relays, that is normally closed NC contact and normally open, that is NO contacts. The letter M frequently indicates the motor starter, while CR is used for the control relays. Now, what is meant by the normally open contact and normally closed contacts? Normally open, that is NO contacts, are defined as those contacts that are open when no current flows through the coil, but it gets closed as soon as the coil conducts the current or it gets energized. What is normally closed contact? Normally closed contacts are closed when the coil is de-energized. That means no any current flow is there. And it gets open when the coil is energized. Each contact is usually drawn as it would appear with the coil de-energized. So here figure shows the symbol for coil as well as associated contacts. M letter indicates the motor starter while CR indicates the control relays. So figure here shows a typical control relay which is used to control two pilot lights. See here in this figure we are going to use two pilot lights. One is the red and another one is the green. The figure above shows the circuit when the switch is open, and the figure below it shows the circuit when switch gets closed. When the switch is open, the coil is de-energized, and when the switch is closed, the coil gets energized. When the switch is open, coil CR is de-energized. As the coil is de-energized, the circuit to the green pilot light is complete, because here the normally closed contact is connected in series with the green light, and so that the green light gets turned on. At the same time, the circuit to the red pilot light is opened through the normally open contacts. So this light will be in off condition. When the switch gets closed, the coil is energized now. The normally open contact now becomes normally closed, so that the red pilot light will turn on. And at the same time, the normally closed contact now opens and it will turn off the green pilot light. So in this way, the electromagnetic controlled relays are used. Control relay coils and contacts have separate ratings. Coils are rated for the type of operating current, that is either DC or AC, and normal operating voltage. Contacts are rated in terms of maximum amount of current the contacts are capable of handling at a specified level of voltage and time. The control relay contacts generally are not designed to carry heavy currents or high voltages, and the contacts are usually rated in between 5 to 10 ampere, with most common rating for the coil voltage being 120 volt AC. Our next field device is the contactors. So what is mean by a contactor? A contactor is a special type of relay which is designed to handle the heavy power loads. These heavy power loads are beyond the capacity of electromagnetic control relays that can be handled by a contactor. The figure here shows the three-pole magnetic contactor. These contactors are designed to make and break the high-powered circuit without being damaged. These contactors consist of the stationary contacts as well as the movable contacts. It consists of a coil which is connected to a movable iron armature or a plunger. Okay, it consists of the line side as well as the load side. So figure here shows the coil symbol as well as the symbol for the contacts. So contactors are designed to handle the high powered circuits. Which are those high powered circuits? So these high power loads include the lights, heaters, transformers, capacitors and the electric motors. For these heavy loads, the overload protection is either provided separately or it may not be required. A programmable controllers normally have an output capacity capable of operating a contactor coil, but not that needed to operate heavy power loads directly. The figure here shows the application of a PLC which is used in conjunction with a contactor to switch the power on or off to a pump. The output module is connected in series with the coil to form the low current switching circuit. You see here the output of the PLC is connected with the help of PLC output module to the contactor. The contacts of the contactor are connected in series with the pump motor to form a high current switching circuit. See here, this is the high current switching or high current wiring circuit. So in this way, the contactors are used to drive the low current wiring into a high current wiring. Our next field device is the motor starter. A motor starter is designed to provide power to the motors. A motor starter is made up of the contactor, which is used along with the overload relays. These overload relays are attached physically to the contactor and electrically to its these motor starters is made up of the contactor with an overload relay which is attached physically and electrically. The function of the overload relay can be summarized here. So why these overload relays are used? Overload relays are designed to meet the special protective needs of the motor control circuit. They allow harmless temporary overloads that occur when a motor starts. The overload relay will trip and disconnect power to the motor if an overload condition persists. The overload relays can be reset after the overload condition has been corrected. Now, where these motor starters are used? Here, the figure shows the diagram of typical three-phase magnetic motor starter. It includes the start button, the stop button, the overload relay, the motor coil. Again, three motor contacts are there. Okay, and a three-phase motor is connected in series with the motor contacts. When the start button is pressed, coil M gets energized. When the coil M is energized, it closes all normally open M contacts. So these three M contacts which are normally open gets closed. The M contacts which are in series with the motor closes to complete the current path to the motor. So these contacts are part of the power circuit and must be designed to handle the full load current of the motor. The control contact M, which is used across the start button, closes the ceiling, the coil circuit, when the start button is released. This contact is the part of the control circuit and only required to handle a small amount of current needed to energize the coil. An overload relay is provided to protect the motor against the current overloads. The normally closed relay contact OL opens automatically when an overload current is sensed to de-energize the M coil and stop the motor at the same time. Motor starters are available in various standards. When the PLC needs to control a large motor, it must work in conjunction with the starters. The power requirements for the starter coil must be within the power rating of the output module of the PLC. So in today's session, we have identified three different field devices which are used along with the input-output modules of the PLC. I hope you all understand the concepts of electromagnetic control relays, the contactors, and the motor starter. Thank you all.